Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, can you hear me? Assalamu alaikum. Hello.
عليكم السلام.
MashaAllah. Finally, somebody answered. Thank you very much. Okay. Now I will say something, but maybe at minute number 5. Until then, we'll just give a few minutes for the other guys to join. Even though this is a very bad practice to have to wait for students to join, we're supposed to start maybe after 1 minute. Right? Do you agree? Because we only have 1 hour plus. Okay, this plus is flexible, can be half an hour or yesterday I finished at 4 o'clock. We'll cover 2 chapters, that's a different subject. Because we have very limited number of classes, because of time clash, especially in Ramadan. So we have to compress. That's why I ask you guys to watch the recording. If you have to leave at 3 because of another class or some other engagement, please make sure you watch the recording. Watch the recording, especially this class. This class, there's a lot of work that you have to do. You must understand. And when you answer in the assignment, especially in the exam, you need to answer in a way that, same as we will be discussing, that we have discussed last time and we'll be discussing today, inshallah. So not only plain, direct copy and paste. That will not take you anywhere. I know some students are really good, mashallah. I remember last semester, actually, I had very, very bright students. Some, the good is rare, the really, really good students are rare. So I would say about 10, 15, 20% at the most. The rest is just, well, maybe they have their own circumstances. But anyway, I hope, inshallah, this time you really need to understand this. It's very important, especially this number system that we're dealing with. Very important that you understand how it works, because if you will be involved in these things, it takes time to learn. Of course, even if you haven't learned it previously and you have to learn something on the job, because of the pressure to learn, you will learn. But if you have had a prior idea, some knowledge earlier, it will be much faster. And if you are always ready, if your mind is like math-oriented, numbers-oriented. I know some people, well, myself included, I like numbers. My youngest son is also, mashallah, good in numbers. The others, not as good. They have to think more. Sometimes the numbers are very quick, especially if you have been dealing with numbers. So we are dealing with numbers. Okay, I shared with you, I did send you a message that I sent you an earlier lecture which covers chapter 1. The problem is last lecture, which was what? Sorry, 2 weeks ago. I muted because I have to clear my throat. After about when I went to the, as I mentioned to you also immediately after the class, I went to the calculator to show something with the calculator, and then I went back to the PDF file. But I forgot to stop sharing the calculator and share the PDF file, and nobody alerted me. This really like stabbed me, just like somebody stabbing me. For you guys, those who remained with me, to just care less about reminding me, oh, we cannot see the PDF file. Ari, whatever you're explaining, we cannot see. We just see the calculator. There were about 6 guys, I think. Nobody alerted me. Nobody sent anything, which means They were nowhere. Only their names were there. So that really made me very upset. And you wouldn't want to make your lecturer upset, because that has usually detrimental repercussions. Anyway, big words. That's why I decided to search for my old, instead of repeating the thing for you, to search for an older lecture that I have given. I found one, alhamdulillah. I shared it with you. Very important that we go over it all the way. It's 1 hour and a half, which is almost same as what I covered last time, but with the calculator not in front. And I have decided to bring my own calculator. Okay? My own Casio calculator. I have had this, alhamdulillah, for many, many years already. Okay? And I would like you to have your own calculator. And for those of you, I think we have one student who is on campus. He will need to be using the calculator. You cannot use the calculator, still can use the calculator or the computer. So you need to use your own calculator. I'll be asking you questions. I will do it on my side, and I will ask you to do also on your side. Use your either computer calculator, or if you have calculator, or your hand phone calculator. Hand phone calculator is not that good. I have previously downloaded the good scientific calculator, which was really very good. Anyway, so today I will continue from where I finished last time. So for some of you, there may be, the latter part of chapter 1, the things that I did explain, but nobody alerted me. You will see them again in the shared file that I shared with you. Please make sure you download it. Okay. When you download that file, you need to go to your LMS email and check on your right hand top right corner, your profile. Make sure that is the active email, or that is the default email, the LMS. Then click on the link. Then you can download that link. All right. Otherwise, if you use your Gmail, it will not accept. So please make sure your email, LMS email, is the default one or the active one. If you have other ones, just close that email, open the LMS from the student portal, go to the icon, the envelope or letter icon, go to the email, and then open that email that I sent to you and click on the attachment that is shared with you. Please download it, watch it, take your time. You can speed it, you can go back. That's the beauty of having the file downloaded to you, that's available to you, instead of having to wait through the internet in the cloud, and it will be a bit slow. Usually it is slow. Okay, enough of this. Let's go to the chapter and share. Foxit PDF. Okay, now we are in chapter 2. Chapter 2 is basically a continuation with the number system that we started with in chapter 1. So chapter 1 was more like an introduction. Here we will have some continuation, and after this also we will go to jump to chapter 6 because there's some more numbers. Then we come back to chapter 2 to continue with the parity and some other stuff there. Okay, so I think there are some guys who have not joined yet. I think they will have to watch the recording. As I mentioned previously, if you miss any lecture, you need to watch the recording, make a summary of what was explained there, 1 page, send it to me by email. I consider you as being present, inshallah. Of course, make a summary by hand. All right, so without further waiting or losing time, not wasting, losing time. Okay, okay, now binary to decimal conversion. We have seen this already. Okay, binary to decimal conversion. We have seen this. So for example, we want to change binary to decimal. We multiply every bit by the weight of its position. So we have 11011. We read it from the left to the right. 11011. So this is 11011. We find the value of each position. So we can use 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. And by the way, we indicate power on the keyboard with this hat, because on the keyboard there is no power or exponent. So we use shift number 6 to get this hat. So this is 2 to the power 4. Okay, so we have 2 to the power 0 plus 2 to the power 1. We don't have anything here because this is 0. Then we have 2 to the power 3 and 2 to the power 4. We just add them up. Or we just choose 1, 2, 4, 8, 16, which is the value of these values. See, 1, 2, 4, there's no 4 because it is 0. Then 8 and 16, we add them up. 8 plus 2, 10 plus 16, 26 plus 1, 27. So it is 27 decimal. So 11011 binary. See, we use the subscript there to indicate this is binary, or we just tell you this is binary. So if we have like 111 without any other thing, so this could be 101 or it could be 111 binary. If there is no indication of what number system this is, then it is always decimal by default. But if it says binary or it has the subscript there, it means this is base 2, which is binary. All right. So this is the way to convert from binary to decimal to know the value. Because if we just say 11011, what is this value? Maybe if you're not very familiar and dealing with ones and zeros for a long time, it's not easy to figure it out. So convert to decimal. This is 27. All right. Actually, this is 1, 2, 4, 8, 16, 32. So these will be 31 minus this position, which is 4. 31 minus 4, which is 27. So there is a shortcut, but after you have some more practice, then you can gain some insight into how to deal with these numbers. Okay, another example. We have this longer series of bits. We have, see, we read from left to right. 1, 0, 1, 1, 0, 1, 0, 1. So to convert to decimal, we multiply by 1 times 2 to the power 0. We put 2 to the power 0 and the power for the position, and then we add them up. Or you just use 1, 2, 4, 8, 16, 32, 64, 128 that we have done last time. Okay, so we have 1, 4, 16, 32, and 128. You just add them up. 128 plus 32, this is 160. 16 plus 4 is 20 plus 160, 180, and 181. So this is 181. Okay, so you should be able to do this thing mentally. You don't always have to use hand addition or calculator. Of course, you can use calculator to double check, to verify your answer. All right? So these things you need to do. All the examples that we cover, all the questions, everything you have to do at least twice, I would say. You do it once, it will be a little bit slow. Do it a second time, okay, do them all. Or do each one twice, and then come a third time. It will be much faster. This brain, because this is like a new language. It's a new language. And language, you learn language by practice. All right? So, for instance, this is 111 binary. What is this value? This is 1, 2, 4. 1 plus 2 plus 4, 7. So this is 7 binary. This one, what is the value of this binary number? So 1101. So this 1, 2, 4, 8. 4 plus 8, 12 plus 1, 13. So this is 13 decimal. All right. So these are easy. The more you practice, the better. That's why in the assignment, some students said, oh my OMG, they said, why so many questions? Well, because you need to have more practice. If you feel you have gained enough, you've gained, like you know it already, enough of practice, you don't have to do all the questions. You can do maybe 70%, 80%, as long as you have become really good at them. To do them all is the best. To copy the answer is loser style. Okay, because you have to do them in the exam. You need to do them, and I will check the way you do them. Okay, I can tell if you have copied or if you understand. All right, so please take the time to do these things and understand how they are done. Those review questions also, please make sure you do them. The answer is always at the end of the chapter. And by the way, all the questions of this book has a solution book, which you can find on the internet. I mentioned this to you. So it is good way, actually, you should get that solution book. You should get the solution book to verify your answer. How otherwise you're going to verify your answer, especially when the answer becomes more, not only numbers, as we will see, becomes more involved. So you need to get to know the actual answer. Then you can check, is this your answer? No, then see what is your mistake, then do it again until you get it right. And then do it a second time or a third time as well. Okay, so binary to decimal, we have seen how that was done even last time. So these are just two more examples. Guys, can you hear me clearly? Can you see the PDF file? Are you with me? Okay, we have 1, 2, 3, 4, 5. Thank you very much. I'm very happy when all of you answer. I feel really very happy, feeling that you are paying attention, because this is very important. If you don't pay attention, it will take longer time to really understand this. Okay, so let's see, decimal to binary. Okay, let's continue with these. Are they okay? Let's see. We have 1001100. What is this number? Okay, my style is to use this 1, 2, 4, 8, 16, 32, 64. Because if there's another one, we go to 128. Another one, we go to 256. Okay, so let's see. We add the value of these ones to get the decimal value, equivalent value of this binary number. So this is 64 plus 8 plus 4. So 64 plus 8, 72, plus 4, 76. So this is 76. Oh, there it is. Okay, I didn't know. All right. Now, this one, let's see. This is 1, 2, 4, 8, 16, 32, 64. So 1, 2, 4, 8, or it's the same one. It's the same one. Okay. So the same one. No, this is 108. 1, 2, 4, 8, 16, 32. So 32 plus 8, 40, 44, 45. So this is 45. All right. Okay. Now, what we want to do is to go from decimal to binary. From decimal to binary, we do the opposite using this 1, 2, 4, 8, 16, 32. Okay. One way to do it is to see. Now, this 45, which ones of these does it contain? Because there's only a unique combination of these numbers that will add up to 45. So we start with the largest, that is before 45, because we go like 1, 2, 4, 8, 16, 32, 64. Of course, there's no 64 here, because it's higher. Is there 32? Yes, so put 1 for 32. Is there a 16? 16 plus 32, that will be 48 or larger, so there's no 16, so put 0. Is there an 8? 8 plus 32, 40. Yes, there is 8. It is still less than 45. Okay, is there a 4? 4 will be 44. Yes, there is a 4. Then we need 1, so there is no 2. So this is 101101. This binary equivalent to 45 decimal. All right, which is what we have done there. 101101. 101101. 101101. Okay, so this is how to do the 45. This is one way. The short way, the quick way, the way I would like you to answer. I know some of you will probably follow this. If you are good with numbers, with simple addition, you will be okay with this, inshallah. And this will save you a lot of time. But the other way will take about 5 times more. This will probably take you 1 minute, 2 minutes, 3 minutes at the beginning, and then it will probably take you 1 minute when you have practice. If you do the other way, the long division, that will take you at least 5 minutes. Well, maybe you can say 4 minutes. Depends how much practice you have or you do. All right. Okay. Let's look at this other one. 76. Again, when we want to convert 76 decimal, of course, this decimal because it has 7 and 6. Okay, has 7 and 6, so it is decimal. If it only ones and zeros, then we suspect maybe binary. If you are told it is binary, then it is binary. Okay, so this 76, we start with 1, 2, 4, 8, 16, 32, 64. No need for 128 because it is larger. So these, which combination of these will give us 76? Definitely we have 64. So for 64, we put 1. 32 plus 64, that's 96. No 32 because it's larger. 16 plus 64, that's 80. No, so 16 is not there. 8 plus 64, that's 72. Less, yes. Okay, so there is 1, 8, 72. Then do we have 4 to make it 76? Yes. Okay, then 76 already, no 2, no 1. So 0, 0. Okay, now you may think I am a bit fast, some of you, okay, which I think I am, because unless you are really focused, then it may be a little bit fast. That's why there is the recording. If I repeat the question 2, 3 times, then we cannot cover much distance or much land, right? So you have the recording. Also, you can just think about it and then compare. All right, so we have 64 plus 8 plus 4, that will give us 76. So the others will be 0. Then the number equivalent to 76 decimal will be, the binary number is 10011100. All right. One thing to notice here, since this is an even number, right? 76 an even number. رقم زوجي. So this one will always be 0. This one is an odd number. رقم فردي. 45 is an odd number. So there will always be 1. Always. Okay, because all the others are even numbers. If you add them, you still get an even number. So to get an odd number, you will have to have 1 as well. Okay, so this tells you if it's 45 and this one is 0, you find out to be 0, then you have made a mistake. If 76, you discover that this is 1 there, then you have made a mistake. All right, so this is one thing to show you that you have made a mistake. All right, so okay, let's look at this number. We have 0, 0, 1, 1, 0, 0, 1. We can still have zeros there, but they have no value. So for this number, we just use 1, 2, 4, 8, 16. No need for this. So what is this value? So this 16 plus 8 plus 1. 16 plus 8, 24 plus 1, 25. So this is 25. The other way around, we want to find what is 25 decimal in binary. So we put 1, 2, 4, 8, 16. No need for 52 or 64 because they are larger. So is there a 16 in the 25? Yes. Is there an 8 in the 25? 8 plus 16, 24 still there. Okay, then we just need 1. So this one will have to be 1. No 4, no 0. No 2. All right, so this is 11001 is equal to binary is equal to 25. We don't need to include the leftmost zeros. We do not need them. They don't have any value. Sometimes, because we usually will be dealing with bytes. Byte is 8 bits. So if you're given a number that is 1, 2, 3, 4, 5 digits or 5 bits, we probably add 3 more zeros to make it 8. All right, but this is not necessary. We will see when we need to do that. Okay, so decimal to binary, we have done that using the, what do they call this? The mentally helping or help technique. Okay, the other technique is using repeated division. Repeated division. Here you need to use a calculator. You may need, okay, for me, this numbers, I don't need calculator. This may be larger numbers. If it's multi-digit, it's faster with the calculator. Okay, so let's see. 25, how much is it in binary? When we convert from, I didn't highlight that. Okay, from decimal to other system, we divide by that base. So from decimal to binary, we divide by 2. From decimal to binary, we divide by the base of the binary, which is 2. If we go from decimal to hexadecimal, we divide by 16. If we go from decimal to octal, we divide by 8. We're not using that. Okay, no, not anymore. So we have binary and hexadecimal. So we want to convert from decimal to binary. Okay, okay. Let's see. To binary, we divide by 2. Okay, so 25 divided by 2, we have 12. How much remains? 1 is the remainder. Because 12 times 2 is 24 plus 1, 25. So divide by 2. 25 divided by 2, we get 12. Remainder is 1. We have to specify this. This will be our least significant bit. Okay, so this 12 divide again by 2. we get 6, and remainder will be 0. So that is 0 down here. Then this 6 divided by 2. Again, we get 3, remainder is 0. Then that 0 goes down here. Then this 3 divided by 2. We get 1, remainder is 1. So this one goes down here. This 1 divided by 0 by 2, we get 0. When we reach 0, this is the final step. So 1 divided by 2, we get 0, and the remainder is 1. So this is the number starting from here. This will be the most significant bit. This is the least significant bit. So this number will be 1, 1, 0, 0, 1 binary. How much time does this take? Maybe 3 times this method. Okay, 3 times I would say. Also, if you have to write these, it takes at least 3 times the time needed to do the one with 1, 2, 4, 8, 16, 34. But so you suit yourself. Okay, you practice both, see which one you are more comfortable with. I would say most students use this way because they are not numbers oriented. Most students, I would say maybe 60–70% of the students use this method. I would say only, well, those who are really good at numbers, it's easy for them to do this. If it's easy for you to do addition, subtraction mentally. Which helps you deal with numbers, okay, maybe a little bit quick aside. One thing that helps you is to just use numbers. How to use the numbers? You know, at home, I used to sit with my children. One of the games that you play as a family, we just say out the multiples of 2. So like we said, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. See, initially, even when I started now, because it has been some time, when I started, I have to pause until I get the number, and then after that it becomes very easy. I have one of my children, one is very quick. Like they will go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 28, 30, 32, 34, 36, 38. As you know, becomes like more repeating. 30, then they repeat 2, 4, 8, 2, 4, 6, 8, so forth. Then, but he will tire quickly. So at maybe 70 or 100 plus, he will tire. Another one will start slow, but then can go all the way to 200, 300 plus. So different people, because if you start slow, but then you warm up, you can go longer. If you go very fast and quickly, and then you cannot go very far. SubhanAllah, different people have different capabilities. So anyway, you need to look at this. So everybody, the same family, you will find some people who are good with numbers and some who are less good. So it's a matter of practice. So even I used to compete with my son. Of course, he's very close. Of course, his experience maybe is not as much as mine. When I was younger, I would say. Now I haven't tried. Maybe next weekend when we get together, we'll probably do this. So, okay, so this is the long division method, which is also good. You divide by the base, get the number, then take the remainder. That will be part of the answer until you reach 0. Then these remainders will be the answer. If you convert them backwards, so this is going to be 1, 2, 4, 8, 16. 8 plus 16 plus 1. 8 plus 16, 24 plus 1, 25. So this is 25. All right. So you need to do these questions by hand. All right. Please take your time doing these questions. Okay. So this is the method in flowchart. Okay. Now, when you divide by the calculator, okay, you divide 25 by 2. What is the answer? 12.5. How do you know there's a remainder 1? The 0.5 is half of the 2, which is 1. Okay, which is what they say here. So 25 divided by 2 will get 12.5. So this 0.5 multiplied by the base, okay, which is half times 2, you will get 1. That is the remainder. All right, think about it. Okay, another number, 37. 37, if we go this 1, 2, 4, 8, 16, 32, it's 32 plus 4 plus 1. That's 37, right? 32 plus 4 plus 1. So this will be 1, 0, 0, 1, 0, 1. Let's see the answer. 1, 0, 0, 1, 0, 1. So 1, 0, 0, 1, 0, 1. So it was 32 plus 4 plus 1. See, very quick. This took how much time? Half a minute, because this is already written. You need to write them down. So, but if you go for the long division, okay, so we divide 32 divided by 2, get 18.5. This 0.5 means 1 remainder. Then take the 18, divide by 2, you get 9, 0 remainder. 9 divided by 2, 4.5. This 0.5 is 1 remainder. Take the 4, divide by 2, you get 0 remainder. Take the 2, divide by 2, you get 1, 0 remainder. Take the 1, divide by 2, you get 0. So it is 0, and 0.5 will give you 1 remainder. So we'll stop here. So this is 1, 0, 0, 1, 0, which is what we found here. 1, 0, 0, 1, 1. Sorry. I'll start from here. 1, 0, 0, 1, 0, 1. I couldn't see that one. There is, because of the writing next to it. So it's 1, 0, 0, 1, 0, 1. So this is the most significant bit, which is the leftmost. If you do like this, okay, maybe I advise you to do like this so that you have them in proper order. So this is the most significant bit. The biggest, this is the smallest, least significant bit. Okay, so this is the other way. All right. So doing it this way definitely takes more time. If you do it this way, and then you put 1, 0, 0, 1, 0, 1 equals 37. That's it. Very short. If you have to do this way, it takes a long time, and then I would say many students will just tend to copy, and when they copy, they don't copy it right. I can distinguish. Okay, so now, okay, going back to the binary. This is binary counting. If we have 3 bits in binary, 3 bits, 2 to the power 3, we get 8 different combinations, which is go from 0 to 7. So this will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is how to count from 0 to 7. So this is 0, 1, 2, 3, 4, 5, 6, 7. All right. How do you know how much is this? This is 1 and 5, 4. So 1, 2, 4. How much is this number? This is 1, 2, 4. 2 and 4, 6. This is 1, 2, 4, 7. This is 1, 2, 3. This is 1. This is 2. Okay, so you need to spend time writing these numbers as well. Then they will be easy to distinguish. All right. If we have 2 bits, we can have 0, 0, 0, 1, 1, 0, 1, 1. So this is 0, 1, 2, 3. Again, this is 1, 2. Zeros. We have here 1. We have here only 2. We have 1 and 2. So it is 3. All right. So, okay. Now, if we have 2 bits, how many different numbers can we get? 2 to the power 2 minus 1. Yeah, the largest. All right, let's go back. We can have 4 combinations, but what is the largest value? 3, which is, that's 2 bits. So 2 to the power number of bits, which is 4 minus 1. So we say 2 to the n minus 1. N is the number of bits. This is the largest number. If we have 3 bits, what is the largest number? 2 to the power 3 minus 1. 2 to the power 3 is 8. Minus 1, 7. So this is 7. The largest number with 3 bits, that can be made from 3 bits, is 7. How about 4 bits? 4 bits mean 2 to the power 4 is 16 different combinations. So 16 minus 1, 15. So 15 is the largest. We go from 0 to 15. All right. So these things you need to really go down, and when you study these things, you study with verbalizing, saying them out loud to yourself. Okay, this is the way to study this. Just like when you study a new language, you speak it out, you say it out loud. Okay. What is total range of decimal values that can be represented in 8 bits. 8 bits, 2 to the power 8 minus 1. 2 to the power 8 is 256. See, we have 2 to the power 0. 1, 2, 3, 4, 5, 6, 7, 8. 256 is 2 to the power 8. Minus 1 to 255. So it's from 0 to 255. 255 is the largest number that can be represented with 8 bits. Right? Okay, 250. So you need to read these. Guys, you have to study. This book is so good. When you spend enough time studying, going through, doing the examples, then you will enjoy it, inshallah. Okay, of course, here I'm going all the way like 1, 2, 4, 8, 16, 32. This is multiples of 2 or powers of 2. 2 to the power 0, 2 to the power 1, 2 to the power 2, because this is 2 the base, so it's always doubling. So it's easy to double every time. So start with 1, then 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 1024, 2048, 40, 96, 8, 192. I think up to here is enough. Very seldom you will need this. But if you double this, so this will be 16,384. Okay, 384. So this will be 32,000 because of this. So this will be 768. Okay, just looking at this and imagine that you add in 2 or multiply by 2. This one, this will be 64, but because the 7 will give us one more, so this 65. Now 65, this will be 4 remaining with 1 from this, so that will be 5. Then 1 out of this, so that will be, okay, now this is, I memorized this actually, but I'm trying to do it. Sometimes you do so many numbers and then you just need to rest. Okay, so this will be, okay, 68 is 120, 136, double 136 plus 1400. So that's 136, that's 1, 5. Okay, so this will be 64, this will be 1536. Okay, 1536 plus 64. So 65, 536. Okay. So with time, you will memorize. When you deal with 2 to the power 16, this is 2 to the power 16. This is 2 to the power 15. This is 2 to the power 14. Okay? So 15 power 15 to 2 to the power 16. 15, 14, 13, 12, 11. 2 to the power 10 is 1024, which is 1K. 1 meg is 2 to the power 20. 1 gig is 2 to the power 30 when we talk about bits, okay, or bytes. Okay, so now 13 bits, what is the largest number? Okay, with 13 bits we can go, okay, just look here. So this is 2 to the power 10, 11, 12, 13. 13 bits we can go up to 8190, so 8192 minus 1, so 8191. Okay, for this you can use a calculator as well. All right, so with 14 bits, this is 16 bit, 15 bit, 14 bit minus 1, so that will be 16383. Okay. All right, so do this review as well. Okay, enough with binary. Now let's go to hexadecimal. Hexadecimal follows the same principle. It's very nice when you deal with these numbers, because then you can use numbers like among yourselves that others cannot understand. That's why why do we use hexadecimal? Hexadecimal is base 16. We said hex is 6, decimal is 10. So hexadecimal is 16. It doesn't mean 16 actually, but it's base 16. So this is the convention, because the 16 in Latin. What is 16? I know octa. 9, I don't know. 10 is desa. 11, I don't know. I know. Is it uno or whatever? Then bi, tri, quad. Anyway, I need to look it up again. Anyway, hexadecimal means 16. All right, so hexadecimal number is base 16. All right, base 16 means we go from 0 to 15. Remember, base 10, we go from 0 to 9, because it's single digit. Base 2, we go 0 to 1. Base 16, we go 0 to 15. All right. So we go to 0 to 15, but we use the decimal numbers 0 to 9, and then for 10, 11, 12, 13, 14, 15, we use A, B, C, D, E, F. So A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. All right. We will need to use this. You need to memorize that A is 10, B is 11. See, you just count. Actually, I used to tell my students, you count. Okay, you put 10 in your head. A is 10, then 10, B with 1 plus 10, C, D, E, F. 5 plus 10 is 15. So use your hand to count. There's no shame in doing that until you can do it mentally. Okay, so we have also the hexadecimal point. So this is the fraction. This is the full number. So the position value or weight is, we start just like we started with the 2's. We have 2 to the power 0, 2 to the power 1. Where was it? 2 to the power 3, 2 to the power 3, 2 to the power 4. Okay, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4. Then the same thing we have with the hexadecimal. So we have the first digit is 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3, and continue. Going to the right, we are the exponent becomes 1 less. So we have exponent 4, 3, 2, 1, 0, then minus 1. 16 to the minus 1, 16 to the power minus 2, 16 to the power minus 3, which is 1 over 16 cubed, 1 over 16 square, 1 over 16. This 16 to minus 4 is 1 over 16 to the power 4. All right? And 16 to the power 0 is 1. Anything to the power 0 is always 1. Right? 16 to the power 1 is 1. 16 square is 256. So multiply 16 by 16. 256, 16 cubed, which is again multiply this by 16. That's 4096. Again, to the power 4, multiply by 16 again. With the 2, we were multiplying by 2. With 16, we multiply by 16. So this will be 1, 16, 256, 4096, 65, 5361. 16 is multiples of 2. 16 is multiples of 2. So we have the same multiples of 2 as powers of the 16 base. All right. So this 1 over 16, 1 over 256, 1 over 4096, 1 over 65536. All right. Okay. So this is the number system showing decimal 0 to 15 in binary. Because we go to 15 with 3 bits, we can go up to 7. To go to 15, we need to use 4 bits. Because we go 1, 2, 4, 8. We have 1, 1, 1. These are 7. Then we need an 8. So this is 15. 1, 1, 1, 1. This is itself F, which is 15. So for hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is same as the decimal. But when the decimal is out of digits, I mean single digit, then we have to go double digit. Still, the hexadecimal can continue single digit. We go to A, B, C, D, E, F. What does this tell us? If we have like 10-digit decimal numbers, when we convert to hexadecimal, because the digits, single digits are more, then if this is 10 digits, hexadecimal may be 7 digits, more or less. We will find out. So we have less number of digits using the hexadecimal. Likewise, for the binary, we have two bits or 2 digits, if you will. So 9 is equal to 4 bits, or single digit. Double digit up to 19, we will have 5 bits. So the more the single digit numbers possible, the less the overall size of the number will be. Okay. So decimal will have 0 to 15. Binary, 4 bits. We start again 0, 1, 2, 3, 4, 5, 6, 7. So the leftmost 0 is not needed, but we can put 0 so that they are all 4 bits. Then after 7, we have to have 8. So 1, 2, 4, 8. So this 8 to have this 8. So the other 1 to 7, 1 to 4 will be 0. Then 8 plus 1, 9. 8 plus 2, 10. 8 plus 1 and 2, 11. 8 plus 4, 12, 8 plus 4 and 1, 13, 8, 4, 2, 14, 8, 4, 2, 1, 15. Okay, just spend some time doing this. Okay, it will be easier every time, inshallah, you go through it. For hexadecimal, we have A is 10, B is 11, C 12, D 13, E 14, F 15. Okay, so you can refer to this to double check what you are doing. Okay, now let's see. Okay, let's look here. We have binary addition. Okay, I think we'll come to this in chapter 16, but I think in the assignment should be after chapter 6. Sorry, chapter 6, not 16. Talk about 16 or the hexadecimal. Okay, so I mixed the 6 with 16. Okay, binary is 0 and 1. So binary addition. If we add binary, 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1 is 2. How do we put 2 in binary? This is 1, 0. This is 2 in binary. This is the 2. 1, 0. Because we have 1, 2, 4, 8. 2 only is there. The others are zeros. So to have 2 in binary, we write 1, 0. We do not read it 10. 10 is decimal. So this is called 1, 0 binary. So this value is 1. There is no 1 because this is 0. So 1, 2. 2 is there. So there is 1 of the 2. So this is 2. All right. Maybe I should have added 1 plus 1 plus 1. 1 plus 1 plus 1. What is the answer? 1 plus 1 plus 1, 3. How do you write 3 in binary? This is 3, which is 1, 2. This is 1, 1. Actually, when I have 1 plus 1, we say 1 plus 1 is 0 with 1 carry goes to the next position. Because we go over the largest value, just like we do with decimal. Okay, let's see. This is decimal. 6 plus 8, 14. To put 4 with 1 carry, that is a 10. Right? The carry here is 10. The carry there is 2. Right? So 1 plus 1, 2 plus 1, 3. So we have 1, then 2 will be carry, even though it is 1 in next position, but the value or the weight of this position is 2. Just like the weight of this position is tens. We have singles, tens, hundreds, thousands, right? So this will be 1 carry plus 7 plus 8, that is 16. We have 6 actually with 1 carry. So it's added with nothing, then the carry goes down there. So this is 100. This is 10, right? Okay. So this is thinking in detail about the value of or the weight of the position where the digit is. Okay. All right. So this you need to memorize. Not really, okay, initially memorize, but you need to write it always so that it becomes like a second nature of you. All right? Okay, now, hex to decimal conversion, multiply. Easy. Decimal to hex, divide. Okay, let's see. Okay. Maybe, okay, I had added, okay, let's see. What is this there? What is this there? Okay, let's see. When we add 1 in decimal or counting, what do we do when we count? We add 1, right? Counting means adding 1, usually. So we go 0 to 9, and then we add 1, add 1, add 1, add 1. 1 plus 9, 10. Actually, no, 1 plus 9 is 0 with 1 carry. Goes there. Then we add 1. The 1 will be added to the lowest digit until we reach 0, and then add another 1 to that one will become 2, right? Likewise, with the hexadecimal, we'll go all the way up to F, which is 15. Then we add 1 when we're counting. Add 1 to the F. F goes back to 0, and then there's 1 carry there. So after F will be 0 with 1 carry. So that will be 1, 0 hex. Add 1 becomes 1, 1. Add 1 becomes 1, 2, all the way until we reach to 1F. Add 1, then F goes back to 0 with 1 carry, with the 1 becomes 2. So this is 2, 0. If you're using a smartphone, maybe it's a bit small. Then 2, 0, keep adding 1, becomes 2, 1, 2, 2, 2, 3, 2, 4, 2, 6, until to F, then add 1, the F goes back to 0, and then 1 carried to the 2 becomes 3, and so forth. All right, so it's very straightforward, just like decimal. We apply the same principle that we do with decimal, even though with decimal we do it inherently because we know it by heart. Here we need to recognize what is happening and use it. Okay, now hex to decimal. Let's see. 256 hexadecimal. We cannot say 256. No, 356. We say 356 hexadecimal or base 16. What is it equal in decimal? We multiply each position by its weight. So this is 16 to the power 0, 16 to the power 1, 16 to the power 2. So 3 times 16 to the power 2 plus 5 times 16 to the power 1 plus 6 times 16 to the power 0. This is 1, this is 16, this is 256. 3 times 256 is 768. 5 times 16 is 80. 6 times 1 is 6. So this 6 plus 80 plus that, then this is the answer, 856. So whenever we want to convert to decimal, we expand, multiplying by the weight of each digit. So expanding 3 times 16 square plus 5 times 16 to the power 1 plus 6 times 16 to the power 0. If there's another digit, let's say we have 7 there, that will be plus 7 times 10 times 16 to the power 3. If we have another 8, that will be plus 8 times 16 to the power 4. Okay, 16 to the power 4 is this. All right, and add it. Then another example, 2AF, hexadecimal. So this is 16 to the power 0, 16 to the power 1, 16 to the power 2. So this is 2 times 16 to the power 2 plus A, which is 10. So we say 10 times 16 to the power 1 plus F, which is 15. 15 times 16 to the power 0. So this is the F, this is A. Okay, A, and this is F. All right, then we just add them up. This is the answer. All right, remember that A is 10, B is 11, C, so use A10, easy to remember. Then from A, you add 1. A10, B11, C12. C12 is also easy to remember. B is also easy to remember. D is the most difficult. 13. If you do them in sequence, it's okay. 13, then E is 14, F is 15. All right, let's go back. Go back here. Let me see what this, okay. Now, 1111 is F, or 15. Okay, this you can memorize. When we have 0 there, there is no 1. See, this is 1, 2, 4, 8. The value of each position is this 1, 2, 4. So this is no 1. So 15, but no 1. So it's 14. This is 14 or E. This one, 1, 2. There's no 2. 15, but no 2. So this is 13, which is D. This one here, 1 and 2 missing. So we have only 4 and 8. See, 1, 2, 4, 8. 1 and 2 are missing. So 3 are missing. So 15 minus 3, this is 12. This one, we have the 4 missing out of 15. So this is 11, B. 1, 0, 1, 0. So this is 1, 2, 4, 8. 1 and 4 are missing. 5 are missing. 5 is missing. So we have 10 remaining out of 15. So this is 1, 0, 1, 0 is 10, which is A. This is 1, 1, 0, 0, 1. This is 8 plus 1, which is 9. Or we can say 15 minus 2 minus 4, which is 6. 15 minus 6, which is 9. All right. So this is the way you think about how to get the value of the number. All right. Please practice this. Watch the recording again. Follow the same manner, the same logic I'm using, the same explanation, and then it will be easy for you, inshallah. But it does need some practice. Okay. So decimal, hexadecimal to decimal is expanding by multiplying by the weight of each position. All right. Now, for practice, verify that this is equal to that. So 1BC to another example. So this is 16 to the power 0, 1, 2, 3. So this 16 to the cube plus 11 times 16 to the power 2 plus 12 times 16 to the power 1 plus 2 times 1. Okay. So this I added them manually by hand. Okay. So you do this as a practice, all right? I want to save some time by not covering that. Let it, I mean, trust you to do it on your own. Okay. Now, decimal to hex conversion. Okay, let me see. I think, why did I write this? I always like to write things to remind you guys. Okay, let's see. These are multiples of 2, right? So I have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so forth. So this goes 1, 2, 4, 8, 16, 32, 64, 128, 256, 2 to the power 8, 5 to 2 to the power 9, 1024 is 2 to the power 10, millions of this 2 to the power 20. Okay, so this 2 to the power 10, then 2 to the power 11, 2 to the power 12, 2 to the power 13, continues doubling because this is 2's. Then 2 to the power 10, 11, 12, 13, 14, 15 to the power 16. We've seen that 65K. This is 64K, which is 64 times 1024. So the K is 24,024 kilobyte. Then multiply double 13, 131072, 262144, 524,288, 104,8576. So this is 1 meg. Okay, maybe this is just a practice also for you to practice as well. Okay, let's see. We want to go from decimal to hexadecimal. What do? We divide by the base. We need to convert 423 decimal to hexadecimal. What do? Of course, this one is, I think most of the time, smaller numbers are easy to do like this, 116 to 56. Okay, but larger numbers, maybe it's easier to use the division, but you'll reach very quickly because the 16 is large, so quickly the number will be reduced. So 423 over 16, we get 26, remainder 7. How do you know remainder 7? We get actually 423 divided by 16. What is the answer, guys? Can you tell me? Can someone tell me? Do it by hand. Do it on the calculator. 423 divided by 16. Somebody? That's why I have this calculator handy, but I have done it already. 423 divided by 16. Can somebody say it out loud or write it in the chat? I need more than one to do this. Come on, let's see who will do it. The first one. You know, if we are face to face, I used to have some candy. And the first student who will do it, I'll throw him a candy bar or candy bar even sometimes, or just like a cookie. Not cookie, not biscuit, no, candy actually, because it's wrapped, you know, with a wrapper. Guys, anybody there? Anybody with me or everybody is gone? Okay, I still have some guys. Yes, okay, what is the answer? 423 divided by 16. Nobody has done it? Please, yes, try. Especially the students on campus. Now the student on campus is with us now. The student on campus, you must do this because you will do it manually in the exam. Others will be online. Yes, 264375. So this is 26 and 0.4375. That's why I wrote it there. So this is the answer. So 26.4375. But they say remainder 7. What is 7? See, this multiplied by 16, you get 7. This is the remainder, which is the fraction. So this is 26, full number, which will divide again by 16. But then this is a fraction, which will give us the remainder. So this 0.4375 multiplied by 16, you will get 7. Then this 7 will go down as the least significant digit. All right? Then we divide again, 26 divided by 16. we get 1 point what? 1 point some value. Okay, 26 divided by 16. What is the answer? Let's see. Calculator. 26 divided by 16. Answer? Yes, 1.625. This 0.625, 1.62, oh, very bad handwriting. 0.625 times 16 will give us 10. Try it out. 0.625 multiplied by 16 will give us 10. This is the remainder, 10, which is A. So put A down there because we're going from decimal to hexadecimal. That is A. Then this one divided by 16, we get 0 and remainder is 1. So this is 1A7. So 1A7 hexadecimal is equal to 423 decimal. How can we verify this answer? Multiply by 16 to the power 0, 16 to the power 1, 16 to the power 2. 16 to the power 2 is 256. Okay. Did I do it on the side? Yes, okay. So this is 256. This is 10 times 16. This is 7 times 1. 7 times 1 is 7. Where is it? Where did I put it? Probably. Anyway, so we have 256 plus 10 times 16 plus 7 times 1. Well, this is 7 times 16 power 0 plus 10 times 16 to the power 1 plus 1 times 16 to the power 2. Okay, add them up. 256 plus 160. 16 times 160 plus 256. 250 plus 160. 410. So 416 plus 7. 16 plus 7. 16 plus 7. 23. 423. All right. Actually, 7 is one of the difficult numbers. We also used to do like 2, 4, 8, 2, 4, 6, 8, 10, 12, 13, and then we do also 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Then it repeats 33, 36, 39. Then we do the 4s 4, 8, 12, 16, 20, 24, 24, 28, 32, 36, 40. Then we do the 5. 5 is easy. 5, 10, 15, 20, 25, 30. Then the 6. 6, 12, 18, 24, 30, 36, 42, 42, which is the multiplication number, guys. We memorized it when we were young, right? Then, so where did I reach? 30, 36, 42, multiples of 6. 42, 48, 54, 60. Then 7. 7, 14, 21, 28, 35, 42, 49. I think I'm remembering the multiplication table, which we memorized, many, many years ago. Then the 8. Then the 9. 9 is very easy because it's 10 minus 1. 8 is easy. It's 10 minus 2. Anyway, I think you will come with some rules of thumb how to do this addition. Okay, so that was one example. Another example, which is convert 214 decimal to hexadecimal. Again, we divide. 214 divided by 16, we get 13.375. So 13 will divide again, but this 0.375 multiplied by 16, we get 6. So this is the remainder, 6. This goes down as the least significant number or digit. Then 13 divided by 16, 0. Remainder is 13, which is D. So D6 is the hexadecimal number equivalent to 214 decimal. If we want to verify 6 times 16 to the power 0, which is 6 times 1, plus D times 16 to the power 1, which is 16. So 13 times 16 plus 6. 13 times 16, you can use a calculator. All right. Then, okay, here the multiples of 16, which will help you decide what is the answer here. So we go 16, 32, 48, 64, 80, 96. Can you do that quickly? 16 is what? 10 plus 6. 10 plus 6, 10 plus 6, 10 plus 6, 10 plus 6. Okay, let's see. 16 plus 16, 32. This I think everybody knows, right? Add 16. So add 16 plus 10 plus 6 plus 10, 42 plus 6, 48. Plus 10, 58 plus 6, 64. Plus 10, 74 plus 6, 80. Plus 16, 96. Easy. Plus 10, 106. Plus 6, 112. So 16 is 10 plus 6. Even 17, if you want to multiply or to add 17 plus 17 plus 17, multiples of 17s. So you add 10 plus 7, 10 plus 7, 10 plus 7. Or you go 20 minus 3, add 20 minus 3, add 20 minus 3. So I think if you do it the first few numbers and you continue, you will be quick, faster. You will be streaming smoothly. Okay, so this is the way to go. All right, so that was hex to decimal. Okay, this explains also that the fraction multiplied by 16 will give you the remainder. All right, okay, let me see what do we have on the side there. Okay, now I think this we mentioned already. This if you start with 2b hexadecimal and you are counting 2b, then you go 2c, 2d, 2e, 2f, and then this goes back to 0, 0, 3, 3, 0, 3, 1, 3, 2, 3, 4, 3, 5, until you go 3, 3, 3, 4, 3, 5, until you go 3f, and then this goes to 0 and 4, so it becomes 4, 0. Then all the way then to 4f, and then 5, 0, all the way to 5f, and then 6, 0, and so forth. Okay, this is counting using hexadecimal. I think this should be a question in the homework assignment that I always ask. All right, okay. Now, hex to binary is very easy. We know the binary, we know the hex. It's very easy. Actually, we have done it. If you got, probably you did not realize. We have done it. Okay, from hexadecimal to binary, every hex digit is 4 bits binary. Every hex digit is 4 bits binary. All right, so this is okay 9f2. What is 9 in binary? 1001. What is f? It's 1111. What is 20010? So every digit will be converted to 4 binary bits. So the binary equivalent will be 1001, 1111, 0010 binary with the subscript of 2, this one. All right, so every decimal, every hexadecimal digit will be converted to or expressed in 4 bits. Very easy, straightforward. Now, BA6. What is B? What is A? What is 6? 6 is 0110. That's 0110. A is 1010. So that is 1010. B is 1011 because I know 1010 is A. Then 1011 will be the B. So this is B. This is A. This is the 6. 4 bits, 4 bits, 4 bits. All right. Make sure you practice doing this. Okay, now D7F9B. Hexadecimal, of course, this has to be hex because it's not decimal, it is not binary, it has to be, it is hexadecimal. So take the D7F9B. So D is 1101, D is 13, which is 15 minus 2. So 1111 minus the 2, so it's 1101. Or 1101. After some time, you just memorize it. You see the shape of the 9, you know this is 9. You see the 1100, you know this is C or 12. You see 1111, this is F. You see 1010, which I call 1010, this is 10 or A. Okay, so after some time, you will recognize the numbers, and then from there, you can get the next number. So this is D1101. 7 is 111 because we put 0 for it to make it 4 bits. Because every digit is 4 bits. So this 0 at the 4th bit. F is 1111. 9 is 1001. This also you will memorize, easy to memorize. B is 1100, 1011. 1011. Usually, if I don't remember, I say A is 1010, which is 1010. Then add 1 to it to become B. That is 1011. So guys, I think this recording, please watch the recording that I sent and watch this recording again and slow it down. Stop it to repeat the thing. Make sure you follow, then continue, go back. Okay, this is the way to go. This is the way to study. All right. So hex to binary, every digit, we express it as 4 binary bits. All right. Now, binary to hex, it's the opposite. We take every 4 bits, express them in binary, in hexadecimal. But we start from the right. For the hexadecimal, it's easy. Each digit is 4 bits. But for the binary, where do you start from? Sometimes you are given 6 bits. You have to add 2 zeros. You're given 7 bits. You have to add 1 zero to the left. If you're given 13 bits, you have to add 3 more zeros to make them 16, which is 4, 4, 4, 4. All right? So if we're given this number, so we have 1, 1, 1, 0, 1, 0, 0, 1, 1, 0. These are 4, 4, 2, 10. We need to mosquito. First time I see mosquito here. So this is, we start from the least most. So take 4, another 4, then these 2, then you put 0, 0. We don't have to put 0, 0 because we know this is 3. Yeah, this is 3. Then 1, 0, 1, 0 is A or 10. A. 1, 0, 1, 1, 0. This is 1, 2, 4. 2 and 4, 6. So this is 6. Okay, so we start from the rightmost, from the decimal upward, from the point upward. So this is 6, A, 3. Of course, it's better to always put 0, 0 so that it is 0, 0, 1, 1, even though these zeros are insignificant, they do not have any value because they are on the left. Right? Now, let's look at this number. What is this number? We have 4, 4, 4, 4, 4. Okay? It could have been without this zero, but you need to add this. What is this? This is 5. 1, 2, 4. This is 5. Okay? So this is 5. 1, 1, 1, 1. We know this is F. Then 1, 1, 1, 0. This is F minus 1. So it is E. 14. What is 0, 1, 1, 0? This is 6. If you remember from here. Right? 0, 1, 2, 4. Sorry. 1, 2, 4, 8. 1, 2, 4, 8. 2 and 4, 6. This is C. This is 12. 8 and 4. 1, 2, 4, 8. So this is a C. So the number is 5FE6C. Right? Okay, let's remove this black. You can just select and delete. So this is 5FE6C. Right? Okay, bring it back, undo, keep the black there so that you can practice. All right? So one hex digit is 4 binary bits. To go from binary to hex, then every 4 bits, we make them 1 hex, but we start from the right. Okay, because the leftmost 0, if it's not there, then it will be less number, but we add the zeros. Okay, so this is 3A6. These are 2 numbers. Counting in hexadecimal, we have counted already. If we reach FF, then we add 1. This 1 plus F16, we get 0 with 1 carry. 1 plus F is 0 with 1 carry, so this is 1, 0, 0. So this is 16 to the power 0, 16 to the power 1, 16 to the power 2, which is 256. This is 256, FF is 255. All right, if you deal more with numbers, then you'll recognize these. So this is counting in hexadecimal. So we'll go 6F8, 6F9, A, B, C, D, E, F, and then FF go back to 0, 0, and 6 becomes 7. What is the use of hex? It gives you a smaller number of digits instead of having so many digits. Okay? So, okay. Decimal 378 exercise. Okay, I'll leave it for you to do on your own. Okay, please do it on your own. Now this thing here, okay, I think typing mistake. See? 37. Oh, okay. 378. Okay, because this is wrong. Okay, let's see what is wrong here. Okay. Now, 378, okay, this is decimal. This is decimal going to binary. Okay. Decimal. We had just been doing hexadecimal, so my mind was still on the hex wavelength, if you like. Okay, let's see. 378 decimal to hexadecimal we divide. Did we do this? No, we did not. Okay. So 378 divided by 16 is 23.625. So it's 23 divided again by this 0.625 multiplied by 16. That will give us 10, which is the remainder. Then 23 by 16 is 1.474375. So this one goes there, and 0.4375 times 16 will give us 7 remainder. So 1 divided by 16, 0 with remainder 1. So 17A is the answer. So 17A. 17A is the answer, decimal to hexadecimal now. Hex value can be converted easily to binary. Oh, okay. So this hex, we want to convert it to binary. That's why this A is there. This is A. 7 is there. This is 7. This is 1 there. These zeros are insignificant. So this is correct. When I looked at quickly at this, oh my God, I said there's something wrong. No, it's correct. It is not wrong. I was wrong. As sometimes, everybody can be wrong. Okay, so we have to read. I did not read when I was, preparing for the class, but then when I go through this, oh, okay, so this equal to that hex. This hex is in binary, so this decimal to binary. Okay, now when we want to go from decimal to binary, we can divide by 2, or we can divide by hex. We'll go to hex, and then from hex to binary, which is straightforward because 16 is multiple of 2, so it's easy to get every digit equivalent to 4 bits. Okay, so when you practice, you will have either way to use. Okay, now go from 16 hexadecimal to decimal. Hexadecimal to decimal. Whenever we go to decimal, we expand, multiply by the weight, right? So this is B times 16 squared plus 2 times 16 to power 1 plus F times 16 to power 0. F is 15, B is 11. So you just multiply it out. Okay, so this is convergence, summary convergence there. Okay, now. So please do these review questions. The answer is given at the end of the chapter. Now, BCD. BCD, this is a binary coded decimal. Decimal coded in binary. Binary coded decimal. Where do they have the full? Why didn't I highlight that? Binary coded decimal. What they call this, but we need to have. Okay. Binary coded decimal. Okay, let me write it down. Binary coded decimal. Binary coded decimal. So decimal coded in binary. This is same as hex coded in binary. Every digit is 3 bits. Here, every digit, 4 bits. 4 bits. The octal is 3 bits. But we're not using octal anymore. So BCD, every decimal digit will be 4 binary bits. So decimal goes from 0 to 9. Oh, binary code, there it is. Should have gone further. So decimal is 0 to 9. Okay. Every digit will be converted to 4 bits. Same as hex to binary. Okay. But this is BCD. Now, so the BCD value, the decimal value is 874. Okay, 874. We want to express that in binary coded decimal. So every digit we use binary notation for it. So the 8 is 1000. So this 1248. 7 is 0111. 4 is 0100. How do you know this? This is 1248. So there's only 4. This is 1247. This is 1248. There's only 8. So this is 1000, 0111, 0100. This is the BCD equivalent of 874. Okay. Now, if we have, let's say, 943 decimal, we want to convert to BCD code representation. So 9 is 1001, 4 is 0100, 3 is 0011. Every digit will be 4 bits. So the BCD number is 100101000011. If we want to do the opposite, okay, we will see. Opposite, then we have to start from the right and take every 4, every 4, every 4. If there is less than 4, then we put 0 to make it 4. Okay? So now we have this number. What is this? This is a BCD number. See, the number can be binary, can be BCD. So this is a BCD, not binary. Why? Because this is what it says. So to convert this to decimal, we take every 4 bits, every 4, 4, 4. So this is 9, this is 3, this is 8, this is 6. So 9386, 9386. So this is 6839 decimal. Okay, which is this one, 6839. Next example, we have this, convert the BCD number, this is a BCD number. So it's decimal equivalent. So we take first 4, second 4, 3, we add another 0 to them to make them 4. So this is 1, this is 1000, then 0011, or that is a bit long. Should be shorter. Okay. Undo. Okay. So this is 4. Okay. Now see, if you count wrong, you are bound to do like this. So make sure you count 1, 2, 3, 4. This is 1, 0011. This is 1100. This is 11. Oh, okay. This is C, but it's not decimal. It is not. So C, and then we have 0111, which is 7. So this is 7. This is 1, but this one is C. C is not BCD. Because we said BCD is binary coded decimal is only from 0 to 9. More than 9, which is this, this is C, which is 12. More than 9 is not allowed. It's not BCD. So this number is not a BCD number, or was generated by mistake. This should trigger an error or an exception. If you say this is BCD, no, this is not BCD. Okay. Likewise, if you have this number, you're given 0111, 0110, 1110. We want to convert this claim, supposedly BCD number to decimal. Okay, we go from the right. We take this 110, 1110. What is this? This is E. This is E. It is not decimal, so this is not a BCD number. This is 6. This is 7. Yes, but this is not a BCD number, so this whole thing is wrong. Okay, so it is forbidden. Now, from BCD to binary, now BCD is not binary. It is representation of the decimal. 444. Okay, 4 bits for each digit. Just like the binary for the hexadecimal, 4 bits for every digit, every hexadecimal digit. So BCD and binary are different. If you are asked to convert from BCD to binary, which I am bound to ask, I will be asking you to convert from BCD to binary. You have to go from BCD to decimal, then to binary. Okay, so BCD, go to decimal. Once you get the decimal number, then you divide by 2, which is the base, or use the 1248 method. Okay, for the whole number. Right? So binary and BCD, some students, they think they put equal and they lose the mark there. So this is binary coded decimal. This is decimal coded the binary, bring it back to decimal and then back to binary. Right? So this, for instance, 137 in binary is this number. But 137 in BCD is this. every digit is 4 bits. But if we were to find the binary, we go 1, 2, 4, 8, 16, 32, 64, 128. See, 128 plus 9 will give us 1. So 128 plus 8 plus 1. So this 1, 2, 3, 4, 5, 6, 7, 8 bits. The BCD is 12 bits. Not the same thing. Okay, so decimal to binary is the normal way that we have just studied earlier today. Decimal to BCD, every digit will be 4 bits. They are different. So if you are asked to go from this BCD number to binary, you need to go to decimal first, and then from decimal go to binary. All right? Okay. Now this gray code, I will skip as I did previously. I think you don't need it. Okay, for the IT students. Putting it all together. Okay, let's look at the table which has all those numbers. Or assignment, make a table to count from 0 to 100. See, I wrote it by hand, I mean in that text. Using decimal, binary, hex, BCD, no need for gray. By hand. Okay, scan and add to the assignment. Okay, so this has up to 15. For decimal, go to 16, 17, 18, 19, 20. For binary, you don't need to put the leading zeros on the left. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, until 15. To go to 16, we need to add 1, 0, 0, 0, 1, and 4 zeros. Then the 17 will be this 16 plus another 1. That's 1, 0, 0, 1, 0, 0, 0, 1. Then the 2, 1, 0, 0, 1, 0, and so forth. For the hexadecimal, after F, we go to 1, 0, and then go 1, 1, 1, 2 until 1F, and then 2, 0, 2, 1, 2, 2, so forth. BCD, we have 0 to 9, then becomes 2 digits equivalent, which is this again will be the 10 is 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and continuing. The gray you don't need to do it. Gray is actually very nice, but I think enough. Binary and hexadecimal decimal is enough for you guys. Okay, byte is 8 bits. We mentioned that already. Nibble is half byte. Nibble is half byte. Okay, where is it? Nibble is half byte, which is 4 bits. Okay, so how many bytes are a 32-bit string? 32 divided by, we want bytes, divide by 8, that is 4 bytes. Divide by 8. Okay, so 4 bytes will give us 32-bit. What is the largest decimal value that can be represented in binary using 2 bytes? 2 bytes. Largest decimal value. 2 bytes. 2 bytes is how many bits? 1 byte is 8. 2 bytes 16. So that is largest decimal. 2 to the power 16 is how much? 64K or 65536. 65536. Oh, okay. 65536, but minus 1 will give us the largest number. So the largest decimal. So there are 65536, all numbers all together, but because we start from 0, then we end with 65535, which is 2 to the power n as the number of bits. So we have 2 bytes, that's 2 times 8, 16 bits. So 2 to the power 16 minus 1 will give us the largest value. In the quiz, you'll have similar questions. The quiz will be after lecture 3. Don't do it. The date is after lecture 3. So after lecture 3, you need to really study for a few days before you do the quiz. The quiz will be on one day, not open for several days. Okay. How many bytes are needed to represent decimal value of this one? In BCD. Oh, BCD. Okay, BCD. Every digit is 4 bits. Every digit is 4 bits. So 2 digits will be 8 bits, which is 1 byte. So I have 1, 2, 3 bytes. Okay. So 4048, that is 1 byte, 4048, 1 byte, 1 byte, so we have 3 bytes. We need 3 bytes to represent this decimal value, to represent in BCD. Okay, how many nibbles are in a byte? 2. Okay, do that on your own. Words, when you say a word is usually double byte. Word size is usually, okay, word is the size of 8 bits. It has, okay, let's see, word size can be defined as the number of bits in a binary word. Usually one word is 2 bytes, but can be more. We have a word size of 64 bits, which is 8 bytes. We can have one word equal to 2 bytes, 4 bytes, 8 bytes, 64, 8 bytes is 64 bits anyway. So it depends on the application. Okay. Alphanumeric code, ASCII code, we talked about this code, I think, earlier. I think this is going to be the last thing. And yes, I think I will stop at the parity. I will not cover parity. So this will be the last thing we will look at, inshallah. So maybe, hopefully less than 10 minutes, inshallah. Okay, this is ASCII code, which is American Standard Code for Information Interchange. This is the code, hex code, that will be exchanged or sent from the keyboard to the CPU, also from the computer to the screen. Okay, every symbol has a hex value and a decimal value. For instance, A, let's go to A. Capital A is 65 decimal or 41 hex. Capital A. Small a is 61. Okay, so every symbol or character has a hex value or binary. This will be 4 is 0100 and then 0000. That is 40. Okay, so everything, for instance, space is 20. I memorize it as 20, which is 0010, 0000. This is when you hit the space bar, this is the code that will go to the CPU. Okay, and so forth. So every symbol has a code. All right, this will be given to you for the on-campus. Maybe this can also be given, right? Because you cannot memorize this. Basically, you need to memorize capital A is 41, small a is 61, the 0 is 30. What are the numbers? Here, 0 is 30, 1 is 31, 2 is 32, 9 is 39. So this is easy once you know the first one. Also, capital numbers are easy so long as you know the first one, because the numbers, I mean, the following characters will just increase by 1. All right. So now let's see. Suppose this is the code that is sent from the keyboard. If space, open parenthesis, x larger than 3, close parenthesis. Write this in the way that it is sent to the keyboard, meaning write this in binary or hex. This is I, small I. Small I is there. This is 69, which is 01101001. So this is 01101001. So this is 6. This is 9. Hex. And then the F. What is the F? The F is 66. So 01100110. So 01100110. Then space is 20. 0010. That is 2000000. Then open parenthesis. Open parenthesis. Where are you? Here. 28. So this is 00101000. So this is 00101000. Open parenthesis. Then the X. What is X? X is this one, which is 78. X is 78. X is 78. And continue. Then larger than, this larger than 3F. This will continue with 0011. Sorry, 3E, 0011, 1110E. Then closing parenthesis, which is 79, I think. Was it? Closing parenthesis, where was it? 29. Closing parenthesis, 29 there, because that's 28, this is 29. So this 0010, 1001, 29. Okay. So this question also maybe in the exam or the quiz, something similar to this. you need to use the ASCII code to write the value in, I would say, hexadecimal, not in binary. Binary will be too messy. To Ronaldo. Too messy, okay? Not Ronaldo. All right, so please read this question. Do the review questions. And I think I will stop here at parity. Let's see. How much is there for the parity? I think I'm tired. You are tired as well. Applications. Oh. I think. Okay, let's do it this way. I will stop here at the parity. I thought of continuing, but that will take about 10 more minutes. I'm already out of gas, as I said yesterday to the students. So let's stop here. Okay, so please read this part. Okay, and then go to chapter 6. Because chapter 3 will be logic circuits. We'll go to chapter 6. We continue with binary addition, representing signed numbers, addition of 2's complement number system, subtraction as well, BCD addition, hexadecimal arithmetic, and 2's complement system. This we will cover next time with the remainder of part 2, chapter 2. And this is going to be covered in the midterm exam, inshallah, which is after the 3rd lecture. All right. So again, I think next time we'll still probably have 1 hour and a half. So please read the section 2.210 and 211 and to the end of the chapter, including the applications, and chapter 6, these things that are highlighted. All right, I said this is the book that I sent to you. Most of the highlights that's already there, you already have it. Okay, guys, thank you very much. Please watch the recording I shared with you. If there's anything that that is wrong, please alert me. Last time I got really upset. Nobody mentioned anything, but again, lucky I didn't have to repeat it, and I wanted to ask you to read on your own. Then I thought I'd share with you the recording, all the recordings. So please, this will require many hours of your practicing, and also do the homework assignment, the questions that are similar to this. Assignment 1, okay? So do the questions that have been covered so that you are ready for next time. Thank you very much. Wish you the acceptable fasting and deed, inshallah, amal salih. May Allah accept from you, and wish you all the health and wealth. And stay safe and healthy until we meet next time. Wassalamu alaikum wa rahmatullahi wa barakatuh. Wa alaikum assalam. I think some already mentioned that. Okay, let's stop. This subject is one of the loveliest subjects because there's just the rule with examples and you just implement. It's very nice when you practice. Inshallah, you will like it. You will love it. Assalamu alaikum.